Hey guys, so we're going to talk a bit today about Android forensics, and that's a very exciting topic because there are so many Android devices around and generally so many phones, and I hope that you'll be able to see the wealth of information that we can get from phones these days. So generally we're going to talk a bit about the Android debug bridge, a way to interact with an Android device from our computer. That makes our life very easy. We are going to just see what types of forensics forensic info we can extract from Android phones. And then we'll just shortly get an idea of how Android apps work and how you can kind of reverse engineer them in case you want to do something like that, to see what types of data the app collects, or to see if an app is safe for you to install, or to reverse some malware that you might have on a phone. Throughout this, I'll try to just show you some stuff on ADB as I'm doing them, so it will be sort of a demo too. Let's talk a bit about the security model of Android and understand why it is built the way it is. So to understand the security model, we need to we can look in the original papers from the developers of Android. An important property of the security model of Android is that they pioneered this three-party consent model. So the idea here is, if you see this linked paper, it's actually very interesting. I can bring it up. This is the paper. So the idea here is that they want the operating system the user to be protected, and for any action, if that action is allowed to happen, all three parties need to consent on that. And the three parties are the operating system, the user, and the application developer, okay, or the application itself. If we get an idea for why that choice was made here, we can take a look at the threat model of their paper and see the threat model of a phone operating system these days is pretty, it's pretty extreme. They need to cover so many different possible attackers. So, for example, they have powered off devices that are under complete physical control of an adversary, okay, or screen lock devices that are under complete physical control. Or they might have like unlocked devices, but they might be under control of an unauthorized other user, like for example an intimate partner abuser, for example, right? Or a border control voluntary submission, right? We can have like network level intruders, like people who are eavesdropping on our communication, right? They can see, or maybe they can man in the middle even TLS connections. So they try to make that pretty hard, but it can be done, especially in a rooted phone. We might have applications attacking us, applications attacking other sensitive applications, right? We might have a game that we installed, and we think it's just a game, but that game might be trying to extract, for example, funds from our Bitcoin wallet that we also have installed there, right? Or it might be able to infer, what we're doing with our banking account, or, for example, famous abusers like the Facebook mobile application that can eavesdrop on all other applications and send that data back to Facebook for advertising, and they can even, have the microphone on and listening to whatever you're doing, or the camera on and seeing what you're doing, or screen capturing and recording the activities on your phone. So it's a very, very large set of threats that this system needs to kind of be designed to at least try to do something to protect, right? And it's not just a Linux box anymore. Like, it's a way more complex system, right? And for that reason, you can see here, this is where they kind of designed the consent model. I think it's here. Yeah, you see the three-part consent, where you have the user, the platform, and the developer. Okay, and generally, very interesting paper. You can go and see more info on the design, and then they go into details on how they do the sandboxing, how, for example, everything is isolated and contained, choices that, for example, they wanted to have like memory protections on the operating system, like ASLR and write or execute pages and all that stuff, and encrypting the data at rest. All that stuff is kind of laid out here in this design paper. Very, very nice paper. So now that we have an idea of all the possible threats and how the developers are thinking of defending against them, we see that okay, we have the Linux kernel. Indeed, Android is mostly it's based on the Linux kernel, but on top of that, it's quite different, right? And what we see first of all, right, if you remember, like on Linux we have the root user, for example, we have our own user, other users on the system. Here, notice something. It seems that every application is running as its own user. Okay, and that kind of makes sense, right? I mean, because every application needs to be kind of isolated from other applications. So, like we utilize the Unix security model to have our data be private from other users running on the same system. They are utilizing the same model to have every application data being somewhat private from other applications running on the same system. Okay, so Facebook, for example, runs as a different user the application than the snapshot application here, right, or the GPU usage, whatever. Of course, that means they can see different parts of the file system, but they can also share some parts of the file system. They can see, maybe or maybe not, they can interact with each other's processes. The system gives abilities for inter-process communication, because consider something like on a phone, you might want to share automatically from your camera to the Facebook application. You might want to share an image. So in the end, the camera user needs to somehow send some data to the Facebook user here, and Android does that through the binder, and there are multiple ways that it allows for inter-process communication interaction. However, these can be abused, and they are abused, right? That's how security works. They, as I said here, they have this SD storage, which goes back to the idea that you have an SD card that's shared, for data to write, large files there, and there is a shared storage that all applications can see on that system. Okay. Now there are also permissions, and that goes again back to the idea of the three-party consent, because when a developer or an application is installed, it kind of says what types of permissions it should have, right? For example, if you download a game again that is not a multiplayer game, right, and it's some sort of very local, very simple Pong, like let's say I wrote a Pong game that you can play, and it's just a super simple game, and you try to install it, and you see that it might ask you for a network, full network instrumentation permission. There would be no reason for you to, you would need to think why this simple game is asking for these sort of permissions from you when you install it. And this goes back, as I said, to the consent model, where the developer kind of also shields the application shields the user from possible abuse, right? So if that application is somehow hacked, it probably never had access to the camera, for example. Let's say the game that I wrote is hacked, but if it didn't have access to the camera, it wouldn't be able to spy on you while it's running, for example. All these permissions and many other things like the content providers and the ways that this application allows for interaction with other possible applications that might want to talk to it, like this called intents on Android. So these are described in the Android manifest.xml file. So there is a file there, and you can, it's an XML file, so it's very annoying to see, but you can, read it. It's human readable, and you can see what types of permissions, what types of storage locations going to try to access and all that stuff. So for forensics, as we said, Android is based on Linux, right? So if it's based on Linux, we can do what we have learned until now. We can just go in there and start getting data with DD, right? Theoretically, yes, we can do it, and actually that's what we'll end up doing. And maybe we can even do memory. We can even do memory forensics, right? We know how to do that and extract data from dev-kmen, for example, or dev-men. Now, if we were able, like, as Android progresses, and even recently with recent changes, what I'm describing now is becoming harder and harder, like on a non-rooted phone, and I'm going to explain what a rooted and a non-rooted phone is in a bit. But they are trying to make it hard for anyone to extract all the data, because that data can contain very sensitive information from banking apps and all that stuff. Okay, but on a not so super recent Android that is also rooted, you can actually connect to it and extract the disk with DD, and maybe do it through Netcat to extract to the network, and or you can even pull the disk file with ADB. I'm going to show you how that works. So ADB, we need to talk a bit about ADB, because that's one of a very convenient way to interact with the Android device here, and it's a combination of a daemon on the second bullet here, ADBD. Okay, this daemon runs on the device and serves requests that come from the client, right? The client which is running on your machine will ask the daemon to do certain things, like, for example, give you access to a file, copy it from the device, or copy it back to the device, or give you a shell, like you literally have a shell that you can issue commands on the device, and from that shell you can see all the possible packages that are installed. You can start a new application, right, that is installed but it's not running. You can start it, you can kill the application, you can do everything, like more things that you can imagine. You can read logs and all that stuff. So again, if we click on this link, we can go on the official documentation here, and the official documentation is fantastic. You can see how to enable this sort of ADB connection. I think I should have mentioned this here. You need to tap on. Let me see. Yes, enabling ADB. I have it over here. To enable ADB, you will go on your system settings on Android, and you will find something called the build number, where you see, like, the Android level that you have on the system info. You see something called the build number, and you tap that 7 times, I think, right? So you tap it. In the beginning, it doesn't do anything, so you just keep tapping, and then after a while, you will say you're X steps away from being a developer. To enable developer options, right? First, you need to enable developer options, and from developer options, you will enable ADB. So you tap there, and at some point, it's like you're now a developer. So then you can go into developer options and enable, here, build 7 times here. And you enable the Android debug bridge, and you also, if you connect through a USB cable, like I'm doing now, you will be able to enable something called USB debugging, right? So once you do that, you will be able to connect the phone and do things like, going back to the documentation here, you will be able to, for example, list packets. You can say, let's get an idea of some commands here. You might do ADB devices. It will show you all the devices here. You might kill the server or start the server again. You might install an application, right? ADB install, and then you give an APK, which is like an Android package. I'm going to again describe an APK, but let's say you download an application, you go to install it. You can install it like that. You can forward ports. Okay, you can copy files. you can run, as I said, shell here and run shell commands. You see it has ls, it has normal, it looks like a normal Unix shell. It is, actually. You can run the AM, the activity manager, and again start an application or kill an application. You can run the package manager, like apt in Debian, the same thing, like it's called PM here, and you can uninstall an application if you want, or see the permissions, or see the users and all that stuff. Okay, recording a video. Okay, you can do screen recording, or capturing the screen cap. And again, you will be able to read the documentation and see all that stuff that ADB can give you. Now, I actually I can show you how kind of this looks. But if you don't have ADB installed on your system, you can see this video that we link here, and it can help you get up and running and run ADB on your system. And then you will need an Android phone, right? So let's take a look on how it looks. I hope you see here my my console, and I have my Android phone connected there, so I should write ADB devices, and I see a device, right? It's a Pixel 4 device here. So we can let's connect first of all, and we can do ADB shell, right? And now I'm on that device, and if I do ID, it will say check that. It will say that I am user 2000 shell, right? I'm not the DSP or whatever, you know, or whatever. I am just the shell user, and I'm on certain groups that, you know, I can see, I can read the SD card, and I can write on external data and all that stuff, right? So it's pretty interesting. I have ls. Okay, and it's going to, you know, I see like that I'm under slash. I see that it has /proc file system. So if you remember, like from my network forensics, my process forensic stuff, I can go on /proc and, you know, inspect the running processes or try to extract memory, as I said. If I do /dev ls, I will see that again it has many devices here, a video device, but I would also see some disk devices. If I'm not sure which one of these are the disk devices, I can run df. I also have df, right? And it will say dev block blah blah blah. You see here dev block the dev block devices, and the DM here are the disk devices. Okay. And I see various other confusing stuff here. The Android is huge. We don't have to go into everything. But now, as I said, I can run things like, for example, I can run a command called logcat, which is very useful, and it's going to just start giving me logs for, you know, coming from all the phone here, right? Now you see like there are logs. Now my phone is not moving. I will move my phone a bit and see that you will, you see there is a significant motion type of log here. So the pickup sensor, you see the device detected that it got picked up. I'll do that again. You see the gyroscope is sending messages, right? Stopping the logcat now. But you can see like the insane amount of logs that you get just from moving the device a bit, right? And of course, other activities might be sending stuff here. You know, someone tried to route the Bluetooth stats, for example, the battery external stats worker. There you will see errors, right? You will see the power, like for example, you know, battery defender notification, like is plugged true, is overheated false. Okay, so you can see that this phone is charging now. And generally from logcat, you see all the different subsystems, and you can examine what's happening. And of course, it's good to check the logs, especially if you have like sensitive files and applications. You know, sometimes these applications are not as good as you think. They have not been pen tested. They might be leaking stuff on the logs that you don't want there, because other things can read the logs too, right? For example, your messages or whatever. Now we have like, as I said, it's a Linux kernel, so you have stuff like ifconfig, right? So you'll be able to see I'm connected on WLAN. Oh, actually, seems I might not be connected on a WLAN right now. Actually, I'll see if I am. But I can run ifconfig, and I see the different radios here for the device. It has like the the GSM radio and the wireless and all the stuff. I can run netstat, right? As we know, we can see all the connections. This phone is currently connected. Maybe I'm not getting. Because the phone is not connected right now, it wasn't resolving on netstat. So that's why it got stuck for a bit. But you can see like it has like open connections here to various HTTPS servers, and most stuck on FinWait, as we see here. What else can I do? Now, of course, like being, I showed you Logcat, I showed you, I mentioned before like the package manager, right? I can see what packages I have installed. So pm is the package manager command. I can do pm list packages, and it's going to give me back all these packages. And observe that the packages are, they have this weird here naming, like com Verizon, for example, right? Or com Android, or com Google, or ch.protonvpn.android, right? This goes back to something that we'll see in a bit, that most of the programs are written in Java, and there is some sort of standardized way for Java classes to be named under the company, like Java was created by Sun. Most libraries there was under com.sun. Whatever. You might see org.something if it's an organization, not a company. Various other naming schemes here, but just that dotted hierarchical idea is pretty standardized for Java class naming. So we have PM, like we can see all the packages, and as we said, every package is running as a different user, and every package is running by sees their own part of the file system, right? But I have more high-level commands like PM here. I have like a fantastic command, for example, called dump sys, and just too much stuff here. So I can isolate a bit what I want to dump sys. So I can, for example, see the connectivity, as we're looking at the wireless stuff before, right? And I can going to reveal now, for example, that which SSID I'm connected to, but you can see, let me try to see if it says the SSID somewhere. No, it says cellular here. This is my cellular connection on that. You can see the internal IP that has taken from the cellular provider. Pretty interesting, right? And if I grab for SSID, maybe it's not connected now, but let's see. No, I don't see anything. So yeah, because it's not connected, but I can actually let me connect the phone on the Wi-Fi. Of course, if now I'm moving the phone around here. Let me see what's happening. Why it's not connected? Yeah, I asked it to connect to the Wi-Fi, and now it's connected. So if I do again this, now it's connected to my my SID here. It's called Baba Yaga My Star. I don't know if you see. There it is. Yeah, right. So it's WPA2. You see that. So again, you can see a lot of information, right? Yeah, very good. From the SID, you can see the MAC address, base station, and all that stuff. Okay, so dump sys, for example, connectivity. We have dump sys, other interesting stuff, like we might have accounts set here on the phone, and we see that I have, like, for example, my Nextcloud account that connects to Memphis there, and that's my username. And okay, we see we have a Nextcloud account. We have like a Signal account. We have a Viber account here. If I had that phone connected to a Google account there, you would also see that. Okay, and we even see when these accounts were created, right? pretty interesting, okay? And when the accounts were added and all that stuff, okay, if they were deleted. And we can even see, you know, the recent, you know, authentications here for these accounts. And we also see which UID every of these systems, you know, Nextcloud is using this UID, you know, Signal is using that UID and all that stuff. Okay. Now, apart from for account, we might have, like, for example, processes. We might see, oops, no process, it's not DAMSys. I thought there is a DAMSys process, but maybe it's not. Let me see. Okay, maybe we don't have a DAMSys process. Okay, let's see what's going here. No. Anyway, I mean, you can just use PS, right? Yeah, you can use PS, but you will see your own user. However, this phone is rooted, and I will show you in a second how to access the root user. You can see other stuff, like, for example, with DAMSys. Let's stay on the DAMSys stuff, like the recent things that have happened. It's not. Okay. How about usage stats? Okay. You can see the usage statistics. So what happened now, like recently on that phone, the last 24-hour events, you can see that the screen, you know, was interactive. Signal, which is using this name, org.crime.secure.sms. Signal, you know, just resumed, right? And let's see, because recently, the recent thing I did, it was to connect to the Wi-Fi. I don't know if this will be persisted, you know, here in the recent activities, but it is possible that we'll see through this giant, you know, sea of events. We might see that we actually connected to the Wi-Fi, right? Maybe before all this activity with Signal, you know, reconnecting because it wasn't on the Wi-Fi, maybe that's when it actually connected to the Wi-Fi. But you can get a very good idea of all the things that the user has done in terms of timeline here, right? Okay, so what else can you do? You can, let me see. You can examine the file system, right? We can, as I said, we can go on /data, and I'm not seeing anything because I don't have the permission to examine a lot of parts of the file system. You see, maybe I can see this stuff. I can see SD card, as I said, that's shared, so I can read that. Okay, and I can maybe see, you know, for example, the downloads for that user, but I can't see the data of every application, right? Because you know, I'm not allowed. However, as I said, this phone is rooted. That means on Android, most phones come without the root user, because if someone was able to switch to the root user, then you know, it would be game over for all applications. But so you can even SU, you can change the root user. There is no root user by default. However, there are exploits out there for every version of Android, and very fantastic people are kind enough to spend time and do that for all of us, so they can write an exploit for some vulnerabilities in Android, and they go in and they after they exploit the system, and they gain kernel level access, right? They install a root user and they give their user permissions, and then you can have like a normal root user. So you can do SU then, and now you can be root and have full access on all the parts of the file system. And that's what you would kind of need to do to take a full forensic backup of an Android system. Okay, so now you can go on /data, and you can see, like, for example, for me to root this phone, I used MagicSK, and then you can access all the applications from here. So, for example, if you want to see, let's see something extreme now. Let's go on com.android.chrome. Okay, and there we see like the Chrome, you know, the browser on that phone. And if you go on app Chrome here, you will be able to see, for example, if you go on the default user, you will be able to see, for example, the history of that browser, right? And if you do file on it, it's going to say probably just data, but I can tell you that this is an SQLite database, right? Like most applications use SQLite to store preferences and data, so you can just do strings on the history, and then, for example, if you want to see, you know, if I visited GitHub, for example, you will see here that, yeah, I was Googling stuff like whatever, you know, I'm just leaking stuff here from my machine, but like, you know, I was trying to download MagicSK, and then I was connected on this GitHub repo, and I don't even remember what I was doing there. So, yeah, lots of stuff, right? You can imagine you can take this file and then you can move it to your system and examine it. Or you can take a full system image, or if you have a root level access, you can even install Lime, as we said, for the memory forensics, and go extract all the running memory of the system. So that's a small demo here that I think I had for you. Let's continue the presentation now, and let's see. Okay. This is how you install your ADB when you want, and yes, acquiring the physical image from the device. You can see. I think this video is from DFIR Science, our favorite YouTube, you know, forensic expert, and you can follow again the steps on how to do kind of what we just saw. Like you'll connect with ADB, and you'll use DD and Netcat to extract your data, right? You can even forward you know, with ADB, you can forward the port from there, wherever you want, right? And you can do that for Windows too. There is another video that we link here. Now, again, we said that we're going to talk just very briefly for on Android reversing. And again, you might want to do that because you want to see what's happening with an application. You want to see if it's legitimate, what types of permissions it wants. So the idea here is that, as I said, Android apps are written in mostly Java or Kotlin in the beginning, but you can write, like now, in most languages. I think even Go or Rust have frameworks for you that will end up generating you know, a legit Android application, and you can write in your favorite language. So the APK that we said in the beginning, you can install an APK, or you can list, you know, the APKs on the system. It's the Android package. It's just a zip file. Okay, that's the first thing you need to remember. It's just a zip file, and that has a specific structure, right? And we saw, like, for example, we talked about Android manifest.xml before. So if you unzip it, you will see the Android manifest. For example, you'll be able there and examine the permissions, right? That's one thing you should be able to do. So you will also see the code of that application, and you will see a lot of .dex files, right? And dex is a Dalvik executable, because Dalvik is a name, was the name of the main virtual machine that is running on every user. If you remember, go back here. If you remember, DVM, right? Every user is running a virtual machine where the application is executed in the Dalvik VM, right? The DVM here, okay? And as we said, the DEX is the Dalvik executable. It is bytecode, right? That is running on that VM. Now, there is also you can take the bytecode and disassemble it now, like if you want, and make something, make a readable assembly out of it, so you can actually infer what's happening. And we do that both for debugging, but also if we want to patch an executable, we don't patch the bytecode directly. We want to bring it into a more readable format, which is called Smalley. It has like, register A, register B, and copy, put that string on register A, and then put that integer on register B, and do an operation between, this register and that register, and write that on a stack. You can imagine it's just a normal assembly language, right? Now, on more recent Android versions, more recent, past like 5 years or so, not really recent, this Dalvik VM has been replaced by a thing called ART, the Android runtime. And ART is it does ahead of time compilation, so it produces native code for the CPU of that phone. So it takes the application in the beginning, and then when it installs it, it also optimizes it by compiling it to the actual CPU instruction set of that specific CPU you have on that specific phone, right? Because there's not one or two or three. There are many different CPUs that are running on Android phones now. You might have like some Qualcomm, whatever, ARM 64, Qualcomm board with an ARM 64, CPU. You might have like in older times we even had x86 phones, right? You might be running Android on some MIPS, other embedded device, I don't know. So there are many different CPUs that ART is going to take the application and compile it ahead of time to that specific instruction set, and the application is going to be faster, more optimal, because it's going to be running really native code, and not it's not going to be running some VM like DVM that was running before. So there is this pretty good video from Pao, I think, and you can see it. He creates a very small Android application, and again shows you how to take, extract the Smalley code and kind of infer, even extract Java code in the end, so you can see kind of what the application code does by just getting the DEX file in the beginning. And it's an entry-level video. You will be able to understand it. And then at the end, I also have some links to a more advanced presentation for Android reversing. Now, again, routing a phone, as we said before, how do you do it? There are exploits that you can go and find, depending on the type of phone that you have. And if you're planning on buying a phone, make sure that the phone that you're buying has the ability to be rooted. You can browse the XDA forums, which is the place for phone hacking and phone development. And you will be able to see from there if there are existing exploits available for your phone, that you can use them to gain access to your phone and install a root user. Now, once you do that, it's going to be installing set user ID executables, and then if there are set user ID executables on the phone, then you can infer that this phone has been rooted. Now, a lot of applications detect that sort of thing, and they refuse to operate, or they downgrade their trust level for you. For example, banking applications, and more extremely, like the Chinese Alipay application, which you use to pay for any service in China, for example. not just refuse to install itself if it finds a root phone, but also bans your user. So if you have an account and it detects that it's on a rooted phone, it just bans the user, and then you have to create another user, for example. So sensitive application developers don't like their application being examined on a rooted phone, because a lot of protections go out of the window, and then the root user can see their APIs, they can reverse what the application is doing, they can maybe tamper with their backend services and impersonate the application and connect to their backend as the application and annoy them further. So they are really not happy with you having root access to your phone, but it's your phone and you should honestly have root access. Yes, applications will try to detect a rooted phone and annoy you. And of course, there are things you can do, right? If you want to examine an application that has this root detection, you can instrument the application and bypass the root detection. For example, we do that pretty often. But then you need time and energy to do that, and sometimes you just can't be bothered. If you have an application on a non-rooted phone and you want to examine it, okay, you can still pull the data of the application through ADB pool, okay, and you can do PM list and see the path of the application, and then you can go and pull that whole APK from there. And in the older times, there was also this thing called ADB backup, and certain applications allowed, they had to be opt-in to be backed up, but this is again being phased out as Android becomes harder and harder to do this sort of low-level stuff. They want to be more like the iPhone, which is more locked and more annoying to work with. You can get the data folder of the application. You can examine the SQLite database, as I showed you in Chrome before. You can disassemble the code, and then you can even try to go man the middle there. So it's not the slide is not rendering very well. You can try to go man the middle and inspect the application's API calls that it does on the backend servers and all that stuff. Now, to do that, you might need to, if you want to strip SSL, you might need to install your own SSL certificate, trusted certificate in the system, and then in the end, to do that system-wide, you will need to be root to do that. So in the end, you will need to have root access. But there are tricks around there. You can install a fake VPN service, and you can connect through that fake VPN, and then you can get all the traffic there. But if an application has a thing called like certificate pinning that says I'm only talking, I'm only doing SSL with that host that has this specific certificate, then it might be even harder for you to inspect, strip that SSL and inspect what's happening, because your certificate that you will have installed and will be a trusted certificate will not be the one that has that pin. So then to bypass that, you need to go back. You need to have a root phone, honestly, and then you need to instrument the application again and bypass the pinning and make it accept your certificate. Here's a small video that does pinning, but again, most applications don't do that. Only heavily pen-tested applications or sensitive applications that have been heavily pen-tested will implement this sort of countermeasures, right? To do SSL pinning and all that stuff. And if you try to examine a very popular application, like of course, like Instagram or something, then of course, these are very heavily protected applications, right? Finally, here's it's pretty dated. It's from 2014, but it's a good book. You can find the link to the book here. And as I said, there are these very nice videos that go deeper on Art and Dalvik and Android reversing that you can watch here. So I hope that was fun. I hope you see that how much data you can get out of of an Android. Of course, like there are more things that I didn't show you, but you can you can run ADB, for example. I think dumps this location, and then you will be able to get like even the exact location of the phone or the nearest locations as registered. And I hope you use this video as an inspiration to start playing more with your phone and discovering all that cool stuff that it can provide back to you. Thank you guys, and see you next week.